Hi, I'm Keza Senes.
Hello, I'm Fernanda Oliveira. We'll be presenting on the three topics we have read and discussed this week.
We have named this creation The Architect's Must Knows, a look at sustainability, building code, and wood.
Let's start with sustainability. The search for sustainable forms of construction continues to push architects and designers to analyze material life cycles and their environmental impact, amongst other things. But why? Construction and operations of buildings are equivalent to 1/3 of the world's energy consumption and carbon dioxide emissions. That's a really scary number. How can we, as future architects, reduce the ecological footprint of our designs? Well, building sustainably provides some answers. It requires a holistic look at construction, an interdisciplinary one. By practicing integrated design processes, we can collaborate and maximize opportunities for synergies and innovation. Having LEED certified buildings is also a nod towards sustainability. LEED stands for Leadership in Energy Environmental Design. This is the most widely applied program for sustainability, where there are mandatory categories that a building addresses. These include site selection and development, energy efficiency, conservation of material, resources, and more. Lastly, there is the Living Building Challenge, in which we go above and beyond sustainability. With this challenge, there is a higher standard of sustainability in which we move past just making buildings that do less environmental harm and more towards making an improvement in the natural environment and people's well-being. So why is sustainability important? From the transportation of materials to construction to operations, the built environment contributes to significantly fraction of carbon dioxide emissions and to issues such as climate change and environmental degradation. By looking at each material's product data sheets, eco-labels, product disclosures, life cycle analysis, and more on that list, they can determine the best sustainable material. Products with the following sustainable attributes can reduce energy consumption and emissions associated with the manufacturing and transportation of materials.
Now on to building codes. Our textbook defines it as a set of regulations intended to ensure a minimum standard of health and safety in buildings. Allen goes on to say that these are what protect the public health and safety by setting minimum standards for construction quality, structural integrity, durability, livability, and especially fire safety. So without these building codes, the built environment would be dangerous, unpredictable, and unsafe, which is why it's extremely important for architects to really know about them. In the United States, the International Building Code on the left is the one that's mainly used. On the right is the International Residential Code. Both the IBC and the IRC are the US's model building codes. Now, this is a really important table to know. Under occupancy, columns on the left side, buildings are categorized into sections. A stands for assembly, B for businesses, E for education, F for factories, M for mercantile or basically stores, R for residential, and S for storage. Other occupancies important to note are high hazard institutional and utility/miscellaneous, which are not in this chart. It lays out according to the type of occupancy and type of construction, the number of stories and area allowed to have. Looking at a close-up, the different types of construction are basically organized by danger, whereas type 1 and type 2 construction is referring to non-combustible systems like concrete and steel. Type 3, 4, and 5 are combustible systems. Also important to note that each type, except for 4, is divided into A and B. The number of stories and areas are always higher for A. Some strategies can be assigned to expand the limitations in this chart. It is also important to note that these building codes are always changing. Now, thinking of materials, type 1 refers to concrete, type 2 to steel, type 3 to fire-treated wood, type 4 to heavy timber and cross-laminated timber, and type 5 to 2x lumber. These materials also influence the price of construction. The non-combustible systems type 1 and 2 are more expensive than the non-combustible systems type 3, 4, and 5.
Moving on to our next topic, wood. Wood is one of the most common building materials in the US. It is a strong and stiff material that is lighter in weight. These are really important qualities that explain its popularity. Now, there are two types of wood, softwood and hardwood. Softwoods come from coniferous trees, which have needles, whereas hardwoods come from deciduous trees that have leaves. This image shows in detail the difference between softwood on the left and hardwood on the right. Important to know that hardwood is more porous than softwood. Now, wood has to be sawed so that it has a reliable size and can be used in construction. Softwood typically goes through plane sawing, which you can see on the left, while hardwood goes through quarter sawing, shown on the right. Another important stage wood goes through is the seasoning. In this stage, the wood loses its water, which induces some shrinkage. As you can see, different cut locations can allow the wood to experience different shrinking processes. There are tangential and radial shrinkages. These processes can also change the shape of the wood since it can split, bow, crook, twist, cup, or warp. While building with wood is a more sustainable process, it also has its dangers. One counterpoint to working with wood is its combustibility.
A great architectural example that showcases the intersection of sustainability and wood is this building called Teach. It's a sustainable wooden bird observatory. The structure is rebuildable and offers a great experience when inside, as the use of sustainable materials are built in a way that is both circular and modular. This building is a great example of what architects can achieve with the use of wood and the push for sustainability. We'd like to end our presentation with questions. My questions are related to wood. What makes hardwood more desirable than softwood? What are the characteristics that make them distinguishable from the other when simply looking at their appearance and not just the type of tree?
My question is regarding building codes. What are the building types that are divided into A and B? How is that difference reflecting on the building allowances? Thank you for listening to our presentation on the architects must know regarding the subjects of sustainability, building codes, and wood. We spent 6 hours total on this project.